Welcome to EDU World Space.
This is chapter 21, problem number 90. We have two spheres, A and B, and they have equal charges. And we're asked to calculate the force acting on the sphere A. In a case where, let's say, QA equals to Q, let's call this sphere A. And here's sphere B, and the charge of B is also Q. They have the same sign, and they're separated by a distance R. So then the force that the sphere A would be experiencing is basically coming from the Coulomb's law, right? K QA times QB divided by the square of the distance between the two. Since QA and QB, they're equal to each other, and it's capital Q, then the force we have is KQ squared over R squared. So let's look at the direction of this force that QA is experiencing. Since they both have the same sign, then there is going to be a repulsion going on, right? QB is going to be pushing QA away. So then it would be, the direction of this force would be away from sphere B. All right. So in part B, some things are changing. We're bringing in a third sphere called sphere C. And the C is coming, it has initially zero charge, but it's coming in contact with B, sphere B. So let's say QC initially is 0, QB initially is capital Q. This is before contact. And after contact, what's going to happen is they're both going to have the same amount of charge, because charges are going to flow from QB to QC, since they're identical spheres, until both their charges are equalized, right? So QC is going to be equal to QB, and the total charge is 0 plus Q. They're going to share it. So overall, sphere B is going to have Q over 2, and sphere C is going to have Q over 2 as well. Now let's look at how the picture in part A changes, how the force acting on sphere A after sphere C is taken away, by how much does this force change, right? So again, we have QA, nothing changed. It still has capital Q charge. R away from it, there's QB. Now the charge on QB is half. Still, there are away from each other. So if we calculate the force now, it's again KQA, QB over R squared, but this time QB has half the charge that it had. So Q over 2 over R squared, right? So then we have KQ squared over 2R squared. So it's halved the force, right? So did anything else change? The direction of the force change? No. Still, they have the same charge, same sign of charge, which means still the direction of this force is away from the sphere B. All right. Now in part C, what we have is we have QC being Q over 2, just like we calculated in part B, and QA being capital Q, right? This is the initial case. Now sphere C is brought in contact with sphere A. So they're touching each other, right? Which means that they're going to share the charge after contact. Which means Q over 2 plus Q divided by half is going to be their final charge. So QC is going to be equal to QA, and that is going to be equal to what? 3/4 of Q. All right. Now, how does this change the previous scenario? We still have QA, but now we have 3 over 4 Q in it. And then we have QB. Remember, in part B, QB was halved, so we're still there, right? And still they're separated by R. Let's calculate the force. Again, K QA QB over R squared. This time K. QA is 3/4 of Q, and QB is half of Q. So divided by R squared. Then what's going to happen is K 3Q squared over 8R squared. right? It's even getting smaller, the force, because the charges, now the charge of sphere A is actually less, right? Well, does this change the direction of the net force? No, it doesn't. It's still away from B because they still have the same sign of charge. So away from B is the direction of this force.